Hello, everybody. Today we're going to be talking about primary production and nutrient cycling. Here's a quick breakdown of the carbon cycle within the oceans. Carbon dioxide is directly absorbed from the atmosphere into the water, where primary producers will then convert it into biomass using photosynthesis. They're then eaten by consumers, which allows carbon to be transferred up through trophic levels. And when they die, these organisms contribute to the detritus in the water column. Their bodies are broken down by decomposers who also handle organic waste. The remaining waste and detritus will fall to the seafloor as marine snow and become food for detritivores or stored in sediment. Some carbon here is recycled for the formation of calcium carbonate shells, as in the case of this chambered nautilus. The largest pools of carbon on Earth are biogeneous sediments, soil, surface waters, and the deep sea. The atmosphere is actually an incredibly small pool of carbon, which makes every little bit that we add to it matter immensely. Another pool is organic matter, which holds roughly 2 times the amount of carbon that the atmosphere carries. By burning fossil fuels, humans have increased the amount of CO2 stored in the atmosphere, which further amplifies the greenhouse effect. And humans have also increased the conversion of soil carbon to CO2 via agriculture. Despite the decreased activity due to travel restrictions with the COVID-19 pandemic, only a small reduction in CO2 emissions was actually observed.
The Keeling curve is a regularly updated figure showing the concentration of carbon dioxide in Earth's atmosphere. There is a steady increase upward since 1960, with a sawtooth pattern showing the seasonal variations in primary production. Within the ice ages, the atmosphere never contained more than 300 parts per million of carbon dioxide. Yet with industrialization and growing human populations, we exceeded 400 parts per million in May 2013, and the numbers are only climbing. Currently, the atmosphere has about 418 parts per million of carbon dioxide.
Now, with the nitrogen cycle, river inputs, lightning, and the atmosphere are the ocean's chief sources of dissolved nitrogen. Upon dissolving, nitrogen is fixed into ammonia, then into nitrite, and finally to nitrate. Primary producers will absorb some of this fixed nitrogen for use in photosynthesis, and consumers will also use some of this fixed nitrogen for cellular processes. After naturally dying, these organisms are broken down by bacteria and decomposers who are in charge of fixing the nitrogen within the water column. The remaining DOM and POM will fall to the seafloor to become biogeneous sediment, some of which is eaten by detritivores. A small proportion of the sediment will be disturbed by upwelling to recycle nitrogen throughout the water column. The Earth's largest pools of nitrogen are the atmosphere, benthic sediments, and rocks. Smaller pools of nitrogen include soils and the deep ocean. Human activity has greatly disturbed the natural progression of the nitrogen cycle. Currently, more than 2 times the natural amount of nitrogen that ecosystems fix and process is pumped into them by human activity alone. Land conversion, burning of fossil fuels, deforestation, and animal emissions all contribute to nitrogen oversaturation. While short-lived, the slow of terrestrial and air travel from the COVID-19 pandemic caused a noticeable decline in global nitrogen input into the atmosphere and ecosystems.
Phosphorus enters the ocean via dust storms and river input. The waste product guano from seabirds also contributes a great deal to the cycling of phosphorus in the ocean. Phosphorus is absorbed by its primary producers for cellular processes such as making ATP, and waste phosphate is excreted. Consumers eat primary producers, sending phosphate up the food chain. Consumers may also absorb and excrete phosphorus. After dying naturally, consumers and producers are broken down by decomposers, contributing to the detrital pool. Remaining organic matter falls to the seafloor as marine snow. Some mixing in the water column helps keep the phosphate circulating, but much is absorbed into sediment through one-way loss. The Earth's largest pools of phosphorus are benthic sediments and rocks. There is some storage in soils and a very small amount in the atmosphere. As one of the largest sources of phosphorus, guano mining has increased. The mineralized phosphorus is used to make fertilizers. However, increasing fertilizer use has serious consequences. High amounts of phosphorus and fertilizer end up in rivers and eventually seize due to runoff. Excess phosphorus often causes eutrophication, which can be very damaging to marine ecosystems. Overall, altered biogeochemical cycles in addition to climate change means heavy consequences for the future. Such extreme changes put our environment and health at risk. I hope you now can understand the Earth's nutrient cycles as well as how human activity affects them. Thank you.